Okay, so just as a brief kind of set the stage for this, so of course Mackenzie, Boubin, Biofuels Director for the Minnesota Corn Growers Association, we have a board of about approximately 40 members that are divided up into various teams that focus on specific aspects. So one of the teams that I oversee is the team called Utilization. So this was a team probably created about 2 years ago to essentially focus on what are the end uses of corn. So these are our marching orders here. So what are the end uses for corn? I mean, really big ones that come to mind: the livestock sector, the trade sector, ethanol, of course, and then now kind of this emerging new uses space. So this is something where we're kind of trying to look outside of these traditional end-use markets to kind of see where, this diversified, maybe high-value, high-margin markets are starting to emerge. Okay, so what we have done traditionally within the Minnesota Corn Growers is have a research team. So the research team has been around for decades, while the utilization team has just emerged within the last 2 years. So traditionally, of course, what the research team does is throw, I think their budget is almost $3 million annually to just throw things at the wall, see kind of what sticks. We're looking at soil health, tillage practices, human-grade DDG applications, engine technologies, etc. So they're looking at it all. So what we're specifically focused at now is to look at technologies that maybe have incubated for quite a while in that research phase. Proof of concept has been shown, patents have been filed, companies have been created, and they're ready to scale. They're ready to move on to the next transition period. And then this is where we come in, either financially or with our other resources to bear, to see how we can further enable them to be successful. So this is something where, we're looking at so many different avenues again. And I think we're kind of reaching this great stage in our technology right now, where so much of this technology has kind of been incubated, sometimes for decades, that is now kind of coming to the forefront of commercialization. Okay, so briefly also to set the stage. So one of these kind of commercialization materials that is coming to fruition is this bio-based chemical space. Now, traditionally, what is the corn market used in, right? So we have our food, feed, fiber, and fuel. And no one's really come up with a corn-based chemical F name. If you do have one, let me know. I'll add it to the slide. But we are excited about these corn-based chemicals. So again, like I talked about, what is the world kind of looking for? Right now, we're hitting the perfect kind of conjunction between consumer and government-led demand for these sustainable products, right? So in conjunction with consumer wanting it, maybe government creating some incentives for these markets, now we have this technology coming to the forefront that is kind of cost competitive with our petroleum-based counterparts. So it's the perfect moment where a lot of this technology is coming to the forefront, coming to scale, and we're here ready to go. So I just kind of want to set the stage about how important some of these, corn-based chemicals could be to speak to the value of it. So I know it's kind of hard to see in the back there, but so typically right now, the percentage of volume for a barrel of crude oil is about 70% of that goes into our fuel market for the transportation industry. So based off volume of a barrel of crude, 70% into the fuel market. Volume of crude going into the chemical market is less than 5% currently. However, you look at the actual value in terms of monetary gains for those, they're almost at parity actually. So that just shows the huge, huge opportunity that we have within the corn-based chemical space if we can now kind of start to replace some of these petroleum-based products. And nothing's wrong with the petroleum-based products, right? They're here, they're in almost everything that we do. But again, this consumer government-led kind of initiative and next wave, we're here and we're ready to kind of transition. Okay, so I am not a scientist. I am not like Joachim or Betsy, where I really like numbers. But I wanted to kind of put this up there to show you that corn is truly a miraculous plant. My goodness. So we have kind of been talking with researchers, and the amount of stuff that they can kind of bounce off from the glucose sugar molecule is really incredible. I mean, it's almost based off the imagination and creativity of the scientists, what they can kind of, for lack of a better word, science into an existing end-use product. So I don't really know what this slide is saying, but I wanted to showcase again, these are things that we're looking at where the sugar molecule can be converted into so many multitude of end-use platforms. And that's the sugar molecule of the corn kernel part, right? So we know a kernel of corn has cellulose, lignin, protein, fiber. There's all of these end-use platforms that they're looking into. So I think this is boots down. If I leave you with anything today, my part of the presentation. So why are we looking at corn-based chemicals? Why should an end user care? Why should the government care? Why should the consumer care? So for a choice of feedstock, we want to leave the consumer with corn is abundant, corn is affordable, and corn is sustainable. So with those kind of three metrics, we hit really that three-legged stool of what those end users are looking for this. So, kind of taking it down to now the Minnesota version. So that was broad, high-level view, global, taking it to Minnesota. So the corn checkoff actually really realized the value of what these bio-based chemicals could create early on, and that was part of the research team. So since 2014, they were actually co-founders of the University of Minnesota Center for Sustainable Polymers. So this is an organization, an entity that was created to, again, look at maybe what the replacements could be, bio-based replacements for current petroleum technology and products. So we, as a checkoff, have contributed about around $400,000 annually since 2014 to this institution. And again, this is a lot of researchers, scientists that are throwing stuff out there, seeing what can happen, and then now maybe you can show proof of concept and take it to the next stage. So, Mackenzie, what is a polymer? So a polymer, a sustainable polymer, has three categories of definition. So 1, it is recyclable. 2, it is durable. And 3, it is degradable. So I try to liken it to a good example of, their marching orders were to find a plastic bag that was heavy and durable enough to carry 2 gallons of milk, but then also disintegrate by the end of the year. So that is what they're trying to create. So this has, again, wide variety of all the different chemicals that they can create here. So, stuff that they currently are making from corn at this Center for Sustainable Polymers are, again, cell phone cases, packaging materials, they have utensils, tires. I mean, it just goes on and on. And again, all these are various chemicals, and they all are dramatically different. So it's a very, very exciting space about all these various things that we can go into. So that's at the research side, and some of them are just not quite there yet for commercialization to scale. But one of the examples I did want to talk about is something that's here, that's now, actually in Iowa this year, well, it wouldn't be this year, last year. So last year, in 2021, they created a plant, they put a plant out there. It is creating butanediol, which is a renewable chemical made from corn that is in use of all things, the spandex industry. So we have corn-made spandex going around in your Lululemon. So that is something that is here, it's here to stay. And again, there's an operating plant right now that currently is estimated to use 8.5 million bushels of corn a year. So that is incredible. And that's just one chemical. So kind of put it into scope and size. The National Corn Growers last year actually came out with a study that said if we could currently replace all the petroleum-based chemical market fully, just with corn-based products, it would be a 10 billion bushel market. That's triple what we currently do. So that's incredible. And again, one chemical, like we talked about, was going into spandex, but this is a wide variety of uses, right? Paintings on your Legos, we have nylons, disposable grocery bags, artificial hips, laundry detergent, we have fire starter, etc. Oh my gosh, the list goes on and on. Like I talked about earlier, I mean, it's really, what is the imagination of the scientists, what they can create. And again, now it's reaching cost competitive parity with these petroleum technologies. So not only does the consumer not have to pay a premium to be green, they can just inherently be green, right? And this is what, again, the consumer is moving more and more toward, as well as a lot of these government tax incentive and initiatives as well. So, we have a problem, and farmers have the solution. So this is where we enter Lateral Technologies. So this is a company that your checkoff dollars invested in June of 2021. So this is a company that actually came out of that Center for Sustainable Polymers. Again, scientists kind of had a eureka moment. Oh my goodness, they had a catalyst, they filed a patent, they started a company, and they're ready to go. So typically right now, a traditional acrylic acid is only being made via the petroleum pathway, via that cracking technology at a refinery. But now, with this Lateral Technologies, they actually found that corn can be converted via lactic acid into acrylic acid. And what is acrylic acid kind of used for? So traditionally, more of those paints, adhesives, but actually the biggest industry it's involved in, the diaper industry. And we go through a lot of those in the United States, don't we? So we have corn-based spandex, we have corn-based diapers, we're doing it all. So again, not a scientist, but wanted to point out again that really big importance. Does this have a pointer on it, or no? Yeah. It does. Okay. So again, the importance of that sugar molecule, my goodness. So the sugar molecule, again, can be converted into lactic acid, and then through their catalyst technology goes to an acrylic acid that has those end markets. So just really, really incredible stuff that can go toward. So right now, globally, the acrylic acid market on a global scale is about a $10 billion market. And that is actually worth, if we replaced it on a full-wide global scale, so corn-based acrylic acid now replaced petroleum acrylic acid, that would be worth about 580 million bushels of corn. So the opportunity is there. Okay, so last June, when this company came to us, we were the very first investor. So we gave $100,000 for this technology to be able to, again, kind of hire staff, look for a research facility, building, further refine their catalyst abilities, etc. So they right now are kind of in that seed stage run-up to actually building a plant. They're looking to build their plant here in Minnesota in 2027. And kind of as a comparison, I wanted to put it on there. So everything with these researchers, they always talk in tons. They don't talk in bushels. But so their single plant, again, just one plant for one chemical, would create about 30,000 metric tons, which would be the equivalent of about 2 million bushels of corn a year. So again, to put it in perspective, that's not what the ethanol industry is. A typical 100 million gallon ethanol plant uses 330 million bushels. So we're not on scale of an ethanol plant, but we're hitting, single bases. We're hitting double bases. And again, this is one chemical at one plant. And I think it, again, further lends to the story and the credibility when we have successful technology like this about corn as a solution for, again, these low-carbon alternatives to these petroleum-based technologies. So $100,000 to hopefully get us, starting in 2027, about 2 million bushels of corn at a Minnesota-based plant. So we're not the only ones recognizing the value of this technology. So we were the first to invest, and I'm very proud of that. Again, we do a lot of due diligence. We have a lot of technologies thrown our way. We try to sift through them and see which ones will be winners, because we want to be good stewards of the checkoff funds. So currently, after we decided to start up in this company, we encourage them to actually apply for the Consider Corn Challenge for national corn growers, which is very similar, where they're looking for type companies that also will have good end-use markets for corn. They actually won that challenge this year. So Lateral Technologies is also getting money from the national corn growers. Hey, Indiana corn growers actually started a similar utilization team. They came to us and they're like, hey, we want to add our own $100,000. So, kind of when we are the first movers on this, it really incentivizes other stakeholders to come to the table. We'll talk a little bit about that moving forward too, but the public image, the publicity about kind of the technology, and again, corn being a solution to this, is coming to the limelight. So we had a great write-up at the Star Tribune. We have some other scientific peer-reviewed literature that came out talking really highly about this. So the momentum is building and the consumer is creating awareness about this. Okay, so let's move off chemistry and into engineering. So we have a problem, like we had in the last one, and farmers have the solution. So currently, the problem is, again, this heavy-duty transportation sector. So there are increasingly strict emission standards that the transportation industry has to meet that get stricter and stricter over time. So one of the things that the heavy-duty transportation industry is looking at to be able to decarbonize the 3 current technologies on the market are battery electric vehicles, hydrogen fuel cells, and natural gas. So none of those are bad in and of itself, but they all come with challenges, right? So the battery electric vehicle is too heavy, it takes up space, so you can't transport as many goods when you're going with your semi. There's range anxiety. Hydrogen technology, while very, very efficient, is very expensive. I think there's a stigma against hydrogen technology in terms of the explosion value. And then we have nat gas, which just does not have the performance factor in comparison to a traditional diesel vehicle. And we also don't have any current infrastructure with natural gas that's set up at our current fueling depots for this heavy-duty transportation sector across the nation. So enter Clear Flame Engine Technologies. So this is a company that has modified the traditional diesel engine, hold the diesel. So it's a normal diesel engine that comes from a normal auto manufacturer. They slightly tweak it to actually run on a higher combustion temperature, so it can run actually on E100. It can run on 100% ethanol. So this solves a lot of the factors that we talked about in the previous slide that those other industries don't, right? Ethanol is cheaper than your traditional diesel, so they're saving money for the fleet perspective. It burns cleaner, so you can get rid of your diesel plug-in filter, you can get rid of the after treatment and the post treatment. Existing infrastructure, right? We have a lot of tanks currently set up at our normal fueling distribution pumps that can handle E100, can handle E85, etc. So there's not a lot of change that needs to happen from the consumer standpoint, from the auto manufacturer standpoint, from the fleet standpoint. So it's all there. And hey, again, it is meeting these stricter and stricter emission standards while also having the exact same performance, the exact same torque as a traditional diesel engine. So they talked about, they had guys come in and they're like, it sounds like a diesel engine. Like nothing has changed. I wouldn't even know you did anything just based off the performance and what I was going on when I drove it. So this is actually a company that we invested in October of 2020. So they were actually are going to start their pilot this year in April, actually down in southern Minnesota, where they have the trucks, they bought them, they retrofitted them with their Clear Flame technology. They loaned them out to a farmer co-op, and they're like, hey, just drive it as you traditionally would for a month. We'll just kind of test it, see what feedback we have, and we'll see what happens. So this is technology that's on the ground, that is coming, and is also Minnesota-based. So I'm also very proud to say that we were the first investor for this. So they came to us, started up in October of 2020. We gave them $150,000 to, again, hire staff, further refine their technology, get an actual building space, etc. And then in October of 2021, they also were able to leverage our funds and raise an additional $17 million from venture capitalist fund Breakthrough Energies, which also happens to be owned by Bill Gates. So I like to say that Bill Gates thought it was good enough for the corn growers, it was good enough for him. So, this is something that is currently proof of concept shown on a Cummins X15 engine. One of the most common engines, I think, on the road today. That's the reason we chose that one. So, proof of concept, that one is working. They are currently in the midst of testing it on a John Deere 9-liter engine. And then again, so, of course, they're working in the heavy-duty transportation industry, but this is a wide variety of factors, right? So they're starting with semis, but this can have tractor applications, it can have electricity generator applications, the list goes on. So we're very, very excited about this. And again, I think bottom line, if I had to tap my foot, if you could take something away from this, is if the clear flame technology was implemented in just 20% of the heavy-duty just transportation market, so again, just in semis, no tractors, we would add and utilize an additional 15 billion gallons of ethanol every year. That's double the ethanol industry currently. And would use an additional 5.2 billion with a B, bushels of corn a year. So we are very, very excited about this technology. Bill Gates is excited about this technology. So, again, look what our $150,000 has leveraged into the industry. So I talked kind of about the two big companies that are kind of our shining stars right now within the utilization team, but we're looking at other stuff, right? We're looking at sustainable aviation fuel. We're looking at those food-grade DDGs. Oh my gosh, the pet food industry, etc. So all of these end-use products that are kind of ready to scale and commercialize. We have a meeting next week to kind of talk about a direct ethanol fuel cell engine technology. We have another one with polylactic acid, which is a traditional like plastic bag replacement that you could do for corn-based technology. So it's here, it's coming, and we're doing great things. So, kind of to wrap it up, we wanted to talk about, again, the significance of commercialization and what these opportunities could mean for significant corn grind. So just two of the technologies that I talked about, would create potentially an additional 1 billion gallons of corn grind, which is just wonderful. We talked about, earlier the slide with the 10 billion bushels, just with the corn-based chemical technology. So it's here, it's coming, this is a really exciting space. And again, if I can remind everyone, so why is corn the feedstock of choice? We are abundant, we are affordable, and we are sustainable. And again, we're reaching that perfect confluence between government and consumer-led initiatives to solve their problem of trying to go to a sustainable market with now this cost-competitive technology that's just coming to the forefront. So it's a bright future for ag. And with that, do we have time for questions, Missy? Okay. Well, otherwise, I'll let you guys on break if there's no questions, and you can certainly talk to me about it.
Where do you think they would, if they use this clear flame in tractors, where would they be testing it? In Minnesota, or? Yeah,
so we always, again, I think we try to leverage our relationship as one of the original founders of the technology. So similar where, we have the infrastructure, we have the most 85 fueling dispensers, etc. I think what they would look for now, what they're doing with their pilot is to actually take farmers who are filling up at the ethanol plant. They're going to fill up after they dump their load and fill straight with E100 right from the ethanol plant, and then go about their daily duty. So they're just going and dumping, filling up, coming back. So that would be their distribution point. Of course, that's not, feasible for everyone. That's why, again, we talk about existing fueling infrastructure already within the state of Minnesota. We certainly lead in that regard. But yes, we're excited about these tractor applications, and certainly would push for, John Deere is kind of being more at the forefront of it now, but for them to get somebody to Minnesota, yes.